All right, question number 7. We want to sketch the graph that has the following properties. All right, so let me look at this. When the first derivative is less than 0, the second derivative is greater than 0. So that means that the slope is negative, or the graph is decreasing on the left side, and then it is concave up because it says greater than 0. And then it says for x is less than -7. Okay, so when we're on the left side of -7, the graph is decreasing and concave up. All right, so let's see. Option A, let me zoom in a little bit, you see a little bit better. This graph is decreasing and it's concave up. It's kind of got like a U opening up shape. And it says x equals -7. So on the left side, that matches. Okay, so A would be a possible candidate based on the first section. C, this graph is increasing in concave up, so I would get rid of that one because it needs to be decreasing. B is decreasing, but it's concave down, opening down. And then D is increasing and concave down. So the only one that actually matches the first section is A. But let's look at one more just to verify. The next section says that the first derivative is less than 0, which means it's still decreasing. And then the second derivative is less than 0, so that means concave down. So concavity switches, and this is from -7 to -5. Okay, so let's look at this one more time. So we're still decreasing, but instead of opening up, it's now opening down. So how that line curves from going up to curving out, that matches, and then it says x equals 5. So that's between -5 and -7. All right, so just based on the first one, I could eliminate all others and decide that A is the correct answer. All right. Go to the next. This one is a review, wants us to use implicit differentiation. All right, so number 8. All right, so there's 2 ways we can do it. I want you guys to pick up on the shortcut. So the shortcut is I'm going to move everything to one side. So I'm going to say sine of x, y. And I'm going to subtract the 2, move it over. So this is -2x. And then -3y equals 0. So move everything over. And then implicit differentiation, you can say negative partial with respect to x divided by partial with respect to y. So implicit differentiation is wanting you to say dy dx, so derivative of y with respect to x. But the definition of partial says just do the partial derivative with respect to x and partial with respect to y over each other. Now, what does that mean? We're going to take the derivative of this function. We're going to treat anything that, every time we see y as a constant. So derivative of sine is going to be cosine. Leave the argument the same because we're going to use chain rule, cosine of x, y. And then the derivative of the inside. Okay, so y is being treated like a constant. X is like a variable. So like if we had 5x, sorry, you can't see that. If I had 5x and I did the derivative, this would just be equal to 5. So imagine that that's the same. This is just going to be equal to y because y is the constant. So it's going to be times y. So we got cosine xy times y. Derivative of this partial with respect to x is going to be -2. Power rule, 1 times 2 is 2, and then subtract 1. Derivative of a constant, because this is 3 times some number, it's going to be a constant. That's it. All right, so we have cosine xy times y minus 2. That's the partial with respect to x. We're going to put a negative out front. All right, then we're going to do partial with respect to y. So I'm going to do the same thing. Derivative of sine, because it has a y in it, is going to be cosine xy. Derivative with respect to y, okay, this is going to be just times x. And then derivative of a constant is 0, because x is being treated like a constant. We're only focusing on y as a variable. Derivative of negative 3y will be negative 3. All right. And so I get a negative cosine xy times y minus 2. I can put the y out front, but this is what we want for our implicit differentiation. All right, so I'm going to say, put the negative out front, and then cosine xy times y minus 2 over cosine xy times x minus 3. That's good.